Hello everyone and welcome to the AANMC webinar featuring Dr. Peter DAdamo on personalized nutrition. We are really excited to have you with us today and to listen to this webinar. AANMC is happy to be able to provide service to our community and are really happy to have you all. So just a couple housekeeping things. Before we begin, please make sure that your control panel is expanded. There should be a box in the upper right-hand corner of your screen, and that is where you ask questions. There is a question box below, and please feel free during the course of the presentation to communicate any questions to either Dr. DAdamo or myself using that box, and we'll do our best to get to as many of the questions prior to the conclusion of the presentation as we're able to. Any unanswered general questions about naturopathic medicine can be sent to info@aanmc.org. I will show this email address again at the end. However, if there are specific questions to the presentation, we may not be able to address them outside of the time constraints of this webinar. If you have any technical issues during the webinar, you can communicate with me using the question box, and I'll try to help you resolve anything as best as I can. So today we're going to hear from Dr. Peter DAdamo, and Dr. DAdamo is a naturopathic physician, an author, a researcher and educator, Ivesian, amateur horologist, software developer, air-cooled enthusiast, and expert knob twiddler. He has really contributed so much to the naturopathic profession, is a New York Times bestseller with the book Eat Right for Your Blood Type. Peter's written over 20 mass market books, 1 medical textbooks, and they've been translated into over 65 languages and have a total sales figure somewhere between 7 and 8 million copies. We are extremely thrilled to have Dr. DAdamo with us today. He's currently developing Opus 23, which is a program that parses the 23andMe raw data and has just always had his hand in so many things. And so with that, Dr. DAdamo, I will be turning the screen over to you and give you control over the presentation. Thank you all for joining us, and with that, please welcome Dr. Peter DAdamo. One second, we'll just take a moment to get you here.
Well, let's see if people see this. Does anybody see a purple screen?
People aren't going to be able to answer you.
Oh, do you see a purple screen?
I do. Mm-hmm.
Okay. I guess I have the floor at this point.
That's correct. Go for it.
Okay. Well, thank you very much. It's a pleasure to be here and to have this opportunity to talk about something that is sort of a birthright, but also too a discovery that my father once said that probably could have only been made by a naturopathic physician. So the advantage of what we share today is that it comes out of the wellspring of the view of nature and relationships and causality and philosophy that typifies what naturopathic medicine is, or at least is to me. My work with blood types started actually about 30 years ago, and let me just show you, that's a picture of me there. I am a what they call a distinguished professor at the University of Bridgeport, where I run something, as it says on the top there, the Center of Excellence in Generative Medicine. And although I'm best known for the work I did with blood types, my current interests run more towards computational medicine. I write lots of software, and as Dr. Yan has said, I'm doing a piece of work now that takes the specificity of the genomic information you can now get from 23andMe and allows physicians to parse it in ways that they can become much more relevantly informed by this tremendous amount of information we can now get 23andMe gives us 700,000 individual points of possible variations between people, 700,000. And, you know, 10 or 15 years ago, this would have been $20,000 or $30,000, and now it's $79 on sale. So one of the nice things about this is that it's going to give the physicians untold of capabilities with regard to personalized and on an extremely specific and discrete level. But basically, I'm going to talk today about one of the most primordial genes that we probably possess, and it's the one that controls our blood type. And this is where my building is at the University of Bridgeport. We have facilities there where we teach not only the actual didactic work. I teach classes in personalized medicine and several classes in some of the more advanced concepts with regard to using bioinformatics, but we also see patients, and some of this information derives itself directly in the form of the real-time information that can inform the decisions that are being made actually right then and there. And you know, I think the basic premise of what to me being a naturopath is something that now is coming into more and more focus, which is the idea that we really do need to personalize the type of medicine that people receive. I think there's a simple formula for disease, but health is very often much more complex and much more specific. You know, there was a famous quote I like by this fellow. It was David Cox, a geneticist. He said, "We're 99% the same, but you could say that humans share nothing, and that would be correct too." And it's kind of like a kind of a facetious quote, but really the reality is that we do share so many things in common that it's easy to think that pretty much everything that we do is pretty much similar to what everyone else does. And yet those variations that we do have, the things that make us different, are the result of heredity, they're the result of the environment, they're the result of developmental changes that we underwent. So for instance, no two things that start out the same ever have the same outcome, because they have different journeys that they go through and different experiences and different ways they adapt to things. And so, you know, essentially the idea was, and this actually was one of the major points, I think, of resistance, because a lot of people really had problems with the theory that blood type had some influence on one's health or on one's predilection for problems, or even more far-fetched, the idea that one could eat a certain way depending upon the outcome of their blood type. Because as medical people, we go back to what it is that we understand and what we were taught. And in medical school, you don't learn very much about blood types other than what the fact is that they screw up transfusions. And that's pretty much all that a person understands and all that's required. You should graduate medical school knowing the blood type relationships that are not going to kill somebody if you give them a transfusion. And yet, if you look at the total of the number of research articles that have been published since the mid-1950s on in particular the ABO blood type, there's about 23,000 articles that have to do with some complication of transfusion. But there's about 7,500 articles that have nothing to do with transfusion. They're just observances of differences in disease and differences in physiology that are specific to one blood type or another. And we'll talk a little bit about that as we sort of build a sort of circumstantial argument as to why this theory has possible merit. So, you know, once again, let's take a look at why blood type. I mean, you know, there's a very basic question. There are 300 plus blood type systems in a human being. So at any given moment, your red blood cells are probably could be typed in any number of different blood typing systems. The two most that we're familiar with are, of course, the ABO system, the system that makes you an A or a B or an AB or an O, and the RH system, the thing that makes you negative or positive. And these are usually put together when a person receives their so-called blood type. So a person would be B positive or A negative, or O negative or O positive. But really, in order to understand the effects of blood type as part of our discussion today, we have to split that up again, because we're only interested in the ABO part of the equation. And although the negative and positive is important when it comes to a mother and a child having the possibility of some sort of reaction, some sort of sensitization that occurs in certain sequence as part of the pregnancy process, the rhesus or Rh blood type, the thing that makes you positive or negative, is really a true blood type. It's only found on the red blood cells of the body, and it doesn't get expressed in any other tissues. So moving away from that towards the ABO system, the thing that makes us A, B, and O, etc., that this is a much more expanded idea of what a blood type is. The chemicals that mark us with a particular ABO type, these are called antigens, are found in tremendous distribution. I'll show you a slide later. They're all over the place, for instance, and so it's actually giving them the term blood type is really kind of in a way been a kind of misnomer, because the idea that they're just found exclusively in blood is the thing that propagates the idea that they ought not to have significance anywhere else. So, you know, how did this all start? I mean, basically, it goes back to this man. He was my father, who passed away about 2 years ago. I am a second-generation naturopath. My father, James DAdamo, first-generation naturopath. Inquisitive mind, a seeker his whole life, very, very classic lateral thinker. At one point, when he was trying to make ends meet in the early part of his career, he worked in a hematology lab in a local hospital, and he would do what are known as blood counts, which back then you did under a microscope and with a glass instrument called a hemocytometer, and you would sit there and literally count the blood cells per little square on this glass thing. And as he told the story, he was looking at the slide of blood, and he was trying to understand why it didn't seem to him that people did well on any particular type of diet that he gave everybody. Why, when he made some people the so-called healthy diet, some people did good. And at the time, you have to remember, this is the 1950s, so a healthy diet is what people would have termed a spa diet, which was, you know, the kind of things that people would do when they went to sanitariums in Europe. You know, I guess you could call it almost a raw food diet or a modified Mediterranean diet. But he came to the conclusion that there were some people who did particularly well on that, and there were some people who didn't seem to do well on it that much at all. And when he was looking at the slide of blood, he simply asked himself, well, maybe there's something in the difference in the blood that could explain why people respond differently to these different types of diets. And then he decided, well, I only have one simple way I could look at that. I could actually just look at people's blood type and see what happens. And you know, medicine is an empirical art, meaning that despite all our best efforts to make it a science on par with physics and chemistry, the best parts of medicine are observational. And in many respects, this was really where the man shined, because in the succeeding 2 decades, excuse me, he simply blood typed many thousands of people and observed essentially when he gave them certain types of foods whether or not they responded positively or negative. And he came up with a basic classic signpost, which was if people were type O, they did better on a higher protein, and if people were type A, they did better on a more of a modified Mediterranean / Asian / vegetarian type diet. And you know, think about the power of just that simple determination when you really come to grips with the fact that there are hundreds, if not thousands, of diet books that are written from the viewpoint that one or the other is exclusively a healthy diet. And to this day, we seesaw between low fat and high protein, and high fat and low fat, and complex this and paleo that. And so we're still trying to fight the notion that basically the field of nutrition can be compressed down to the idea that there is a one-size-fits-all diet. Then humans are fundamentally omnivores. They'll derive calories from almost anything, but as you'll see when we go along, foods can relate to you by virtue of your blood type in ways that actually go far beyond the idea of what calorie count they have or how much cholesterol they contain. So I must admit that, like most people with a medical background, when I went to school as a naturopathic physician back in the late 70s, early 80s, I thought his idea was crazy, because there I was in school thinking I heard nothing that could support the notion that there was any relationship between blood type and diet. And And one of my teachers actually said, well, you know, it's interesting because your father left out an important association between blood type O and ulcers. And I actually remember thinking to myself, wait a minute, maybe that's the missing link here, because my father was not a person to go into a medical lab and do the literature searches or anything. So I thought I would actually then go into a medical library and simply look up the pathologies that were linked to blood types. And it turned out that the vast majority of the ways we understand certain diseases to vary by people of different blood types tend to fit what ought to be recommended that those people consume as a diet for those types of illnesses. So that got me interested, and I basically sort of wrote papers on it and became very much intrigued with it in the subsequent years. And then I wrote this book, Eat Right for Your Type, which actually took that theory of my dad's and subjected it to a whole lot more scientific scrutiny. And surprisingly, probably I was as surprised as anybody else, the book sold an inordinate number of copies in worldwide distribution. I put this thing up here just to illustrate a point that sometimes I need to remind myself of when I say things. If you have a book that sold several million copies, you know, it's hard to imagine what that looks like. So if you took the Cotton Bowl, which was 100,000 people, and made 70 copies of it, you have pretty much the total number of people who have bought a copy of this book and have to some degree or another followed the diet. And the interesting thing is the book Eat Right for Your Type is now approaching it's past its second decade, and yet it's still only available in hardcover. The publisher has never released a softcover version of it. So what really the point being is not that I can sell a lot of books, but rather that there was something in this concept that was easily assimilable, that appealed to people's maybe innate sense of what ought to have been common sense maybe to the nutrition community from a long time ago, which was that, you know, how can we exist in this multi-universe of different diet theories when we do have certain proponents and we have a certain theory and those people have certain adherents, they believe in it because it helped them, and yet other people can write a book that has a completely diametrical conclusion and they will have their proponents and they will have their adherents. And the only logical assumption there is that probably to a certain degree they're both right. And I think ultimately the reality of the whole thing is that there are certain reasons why we were conditioned to go in one direction or the other, and I'll talk a little bit about that as well later. The thing that basically is most interesting about blood groups is really how they relate to a long time ago. And this map shows the distribution of blood group B. And the darker areas are where, if you look at indigenous populations, you find very high concentrations of blood group B. And blood group B, as you can see, was largely located in Central Asia, areas typically characterized by large amounts of prairie and consistent nomadic existence. And here's where it changes. If we look at the distribution of blood type A, we see it's highly distributed in a path that correlates very closely with the movement of Neolithic or agricultural technology and the development of civilization and urbanization. And it actually has a lot of deep sort of correlated type observances, which I'll get to in a second. If you look at the map of type O, we see that it is typically much darker, believe it or not, in the Western Hemisphere. And the reason for that is that probably in the moderately recent past, even though the genes for the individual blood groups are quite ancient, the mutations are quite ancient, because there's something in genetics called founder effect, which is how one genetic population can become sort of purified as it moves along. It turns out that the reason that the Western Hemisphere has such a high concentration of type O is that the earliest migrating people who crossed over the land bridge that existed at one time between Siberia and Alaska essentially had a very high concentration of type O, and then when that land bridge actually was dissolved by the rising water, the other mutations hadn't been numerous enough to really constitute much of a influence. And so until depending upon your theory, Leif Erikson or the Basques or Christopher Columbus came over from the other direction, there just wasn't a whole lot of the gene available for the propagation of the other blood groups. And this is very true in terms of actually observances. You find very high concentrations of type O in populations. In the Basques, for instance, are an excellent example that in parts of the world where people have been there from Mesolithic times and haven't really been disturbed much. There's probably some very good reasons for it, but the two best are really the idea that blood groups convey a tremendous amount of protection against certain types of infectious diseases. And so, for instance, it turns out that probably the reason that the other blood groups weren't particularly numerous until probably more recently than most people are aware of is that type O is a blood group that has a lot of protection by virtue of the fact that it carries antibodies to both blood group A and blood group B. So for instance, if you're type O, you cannot receive blood from a person who's type A or type B. You can only receive from another O. And of course, the big question is, why do we carry antibodies to other blood types? And if you were a medical student, you'd probably answer that with the notion that, well, they're there to screw up transfusions. But they're not. They're there for much deeper reasons. By having one marker or antigen that identifies your particular immunological type, and by having an antibody opposed to a very common immunological type difference than yours, you're kind of drawing a line in the sand with regard to what it is you're going to have a tolerable resistance with and what it is you're going to be intolerable of. And this was a big distinction when it came to, for instance, infectious diseases, because if you list the most common infectious diseases that human beings have been afflicted with, virtually all of them have a susceptibility profile for one blood group and a resistance profile for a different one. So for instance, if you look at plague, there's a little bit more resistance on the part of blood type A. Malaria, they're a little bit more susceptible. Cholera, type O, more susceptible. And typhoid, for instance, type A, more resistant. So if, again, this idea that these epidemic type illnesses had a big shaping effect, but the idea that if you had, for instance, a blood group that could actually have antibodies against two other external markers, well, before the age of antibiotics and public health, that would have been a big advantage. So essentially, I'll just share this other map with you because this kind of shows you an interesting correlation that exists. There's what are called Y chromosome haplogroups, and these are broken down based upon a lot of genetic markers that are found on the Y chromosome. And there are certain haplogroups that are associated, again, with a more of an earlier Mesolithic, Paleolithic existence. And what this kind of map attempts to do is to superimpose the percentages of the older haplogroups, which are indicated by the red slice of pie, with the distribution of blood group O as evidenced by the darker color in the left screen and the rhesus negative blood type, which is manifested by the darker color in the right screen. So what this kind of tells us is that there's definitely a correlation between the age of the population with these two basic blood group markers, which, when you fundamentally break it down, are just genes of a more basic nature. I guess you could say that the blood type diet was probably the first nutrigenomic diet, and it only used two simple genes. I mean, actually, the gene for ABO is one gene, but it's got 4 outcomes. It's an interesting gene, too, because the gene that makes us ABO is on the chromosome number 9, and it's a very dense area of chromosome number 9. And the question's always arisen as to why the area stains so darkly, indicating that there's a lot of chemical known as chromatin, which is an indication that the DNA is very tightly wound in that area. And why would this be the case if the gene locus only makes 3 enzymes? But it turns out that actually, if we start looking at the effect that ABO controls on the outcome of other genes. We start to see that through a phenomenon called gene linkage, the outcome of one ABO allele has the effect of linking and turning on other genes that regulate completely independent genes. So, for instance, a classic example of that is a gene that is activated that controls the metabolism of dopamine that gets changed in its form if the person is blood group O versus the other blood types. And regulation of cortisol, on the other hand, its function is influenced if the outcome is a person of type A. So again, back to the idea of transfusions for a second. You know, this is the history of transfusions in 2 seconds or less. The guy on the left is getting a blood transfusion from a little sheep there. And the guy in the middle is getting a transfusion from a dog. The woman on the bottom is getting a transfusion of salt water and milk. And all of these things occurred up until the handsome guy on the upper right-hand corner, Dr. Carl Landsteiner, determined that the relationship of transfusions was the result of the interaction of 3 different antibody possibilities amongst 4 different blood groups, and that became the basis of the notion of transfusion, and that got him the Nobel Prize and actually revolutionized the practice of modern medicine, because until blood could be transfused with the knowledge that the outcome wasn't going to be lethal, surgery had to be performed literally with a stopwatch in hand to minimize the amount of blood that was lost in the surgery. But once Landsteiner's discovery became known and transfusions could proceed predictably and rationally, well, surgery could then take on the shape that it has now, where we have, you know, blood banks and Red Cross and transfusions and that kind of stuff. So it's been maybe the single most important life-saving invention that's ever occurred, or actually discovery that's ever occurred. The relationship is pretty straightforward. I mean, you know, if I'm type A, so that's me up there. On my cells, and this says erythrocytes, but we'll see later on, your blood type is all over the place. I have an A antigen on my blood cells, and I have antibodies against blood type B. And people who are blood type B have B antigens, which are structurally different, as you can see, and they have antibodies against A. So you can't put A blood inside of a B person and vice versa. 2% of the population is blood group AB, and they don't make any antibodies, and so they could actually receive blood pretty much from anybody. They're called universal receivers because of that. And then the guy on the end there is blood type O, and he has no antigen, and he makes antibodies against both. So he can only receive blood from another O, but he's known as a universal donor because his blood cells don't contain anything that the other types can react against. So usually blood type O people are very they're generally what would I say, popular at the blood bank would be a way of explaining it. But the interesting thing is that there is a marker that is part of blood type O. It's actually called H. And it's like a little stump. It's like if you look at the B antigen, you see that it's like a golf ball on a little stump. Well, H is actually the stump. And if you're blood type O, you have H, and all the other blood types have H. But since all the other blood types have H, they don't react to you because they have it as well. But that's important because you might get the impression that type O is not very reactive to things, as you'll see later on. It actually is, but a lot of times those things actually are specific to the H stumpy molecule that they have. And again, here's just a simple kind of transfusion relationship. Everybody can give to AB, and O can give to everybody, but if you're B, you know, you pretty much need B or O. If you're A, you pretty much need A or O. And again, it's simple, but sometimes people are unaware of just how interlocking it all is. And what do we know about the distributions? They vary quite a bit, as you might expect, because we looked at those maps before. Between certain populations, we find higher incidences of blood groups in different parts of the world, and we see this as probably a residual effect of migrations and changes with regard to susceptibilities and resistance to certain viruses or bacteria or parasites. There's actually hundreds of articles that show differences in infection with yeast and viruses that vary by blood groups. And part of it, of course, is really simple. The fact is that your blood type is just all over the place. It's found, for instance, on your tongue. It's found in your salivary glands. There was a paper written that concluded that there's probably slight differences in the ability to taste between the blood groups because of differences in the distribution of their blood type chemicals in their saliva. Your blood type is found sometimes in your thyroid, and especially when you get colon cancer. And this is an odd situation that's actually worth mentioning. Your blood type is found abundantly in your intestines. And when you get, let's say, colon cancer, it, believe it or not, disappears and shows up in your thyroid. And blood type is not normally found in your thyroid, but when you hit thyroid cancer, it shows up in your thyroid and disappears in your intestines. And a lot of that is because your blood type is a chemical known as a glycoprotein, or in certain instances, a glycolipid. And this fancy word simply means that they took a carbohydrate and smashed it into a protein and made a glycoprotein, or they took a carbohydrate and a fat, smashed it together and made a glycolipid. But in humans and most living things, glycoproteins and glycolipids are very involved in transmitting information. So for instance, if you take a certain type of a glycoprotein that is made in the liver, for instance, and change the sugar on the protein, instead of going to the liver, it goes to the thymus. So a lot of times the body puts these sugars on molecules as a sort of a way that you would address an envelope by putting a zip code on it that kind of tells it where the general vicinity we should send it. And it turns out that the real reason we probably have ABO blood types goes back to when we were fetuses, because the chemicals that make our blood types were actually deposited as we were developing as a way of actually setting the groundwork for where muscles and blood vessels and things would actually wind up being laid down. So it was acting a little bit like a surveyor going ahead of a highway crew saying, okay, this is where we put the overpass, this is where we put the exit ramp. Your lungs are full of blood type chemicals. The lining of the arteries, called the endothelium, is full of blood type. Your liver, what are called the sinusoids and the bile ducts, the area, the little enclosed chemical hood where your liver does all those incredibly toxic reactions that involve detoxifying things, is laced with your blood type chemical. The lining of the stomach, for instance. We know that people who have blood type O have much more of a problem with H. pylori infections, because H. pylori infections loves to attach to that little H marker that's part of the blood type O situation. We see blood type extremely deposited in the mucus lining of the intestinal tract. So for instance, your entire intestinal mucus, the insulation that actually separates you from the internal world that's actually the external world, the actual bugs and food residue and fiber and all sorts of other things that are passing through you, which really is the outside world, is protected. You're protected from that by the mucus lining of your digestive tract, and your mucus lining is embedded with the particular elements of your particular blood type. Ovaries and prostate, anything that you make a secretion of, perspiration, saliva, semen, vaginal fluids, is always got a percentage of blood type in it, because you are essentially, anywhere you're coming in contact with the environment, you're putting your blood type as a way of conditioning the relationship you're going to have with the bacteria and the microbiome that's actually part of that population that exists within inside of us. So if I am bug that looks like blood type O, and I wind up in the vaginal tract of a woman who is blood type O, I might have an easier time of things because I go on to resemble something that's part of her core makeup. If I was blood type B and I wound up in the vaginal tract, I might have a difficult time of things because to her immune system, I represent something akin to a bad blood transfusion. All right. So, you have to pardon me because I threw the slides thing together really fast and I think I have to press buttons at certain points. There we go. All right. So, this is a slide of somebody's blood. Well, under normal circumstances, somebody got stuck in the finger and they put it on a slide and they put it under a microscope. And it looks very nice. It's all very evenly distributed because all the cellular elements are all banging off of each other and they're all spread out really nice. And this is what happens if the cells agglutinate. In other words, the cells get connected to each other. Agglutination is one of those great German words, you know, that not too many German words in medicine, but agglutination is one of them. It's just glue. You can think of it in terms of gluing together. In other words, what happens when a cell gets sticky and sticks to another cell, and that sticks to another cell, and that sticks to another cell. And this, believe it or not, is the basis of how we actually look at people and blood type them. We use a chemical that is known to agglutinate one blood type and a chemical known to agglutinate another blood type, and we drop them on two separate slides of blood, and we observe which one agglutinates. If both agglutinate, they're AB. If the A agglutinates, they're A, but the B doesn't agglutinate, then they're really A. If neither agglutinates, they're O. So the sort of whole point of the whole thing is that actually agglutination is a basic immunological reaction. And by the way, if you are unfortunate enough to have a bad blood transfusion, this is what happens because you are carrying blood type of a different blood group, and your immune system reacts with this agglutination phenomenon because the antibodies that are actually part of the system, the antibody that you carry to another blood group, is a very, very nasty antibody. The antibody that you make to chickenpox is a very simple antibody. For instance, it looks a lot like a wrench that you would use to fix a car. There's a little part in the front that opens and closes based upon the size of the nut, and then there's the handle that you put your hand on. So the antibodies that we make to most things are those types of antibodies. Very simple thing. They got like a little mouth and they got a handle. The antibody that you make to blood groups is actually a star made out of 5 of those with the sort of adjusting part outwards. And so they can latch on to one cell and cross over and cross-link to another and cause this agglutination phenomenon. One of the things that we'll talk about is actually this is what happens if you eat certain types of foods that react immunologically with you based on your blood type. For instance, if that was me on the left-hand side, who's type A, and I sat down and had a plate of lima beans, that's what my blood type would look. That's what my blood smear would look like if you just took the lima beans and dropped them on the slide, or if I ate a lot of them and I had a lot of problems with my digestive tract. So we get on this wonderful subject, which are these things called lectins. And as I said before, I made casual mention that reaction called agglutination can occur if you eat certain types of foods that react negatively with your blood type based upon the fact that the food contains a natural protein that acts as an agglutinin. And the word lectin is, as I said before, we don't see too many German words in medicine, and actually most of the time you don't see too many Latin words in medicine either. It's almost all Greek. And the word lectin was derived from the Latin word legere, which is a kind of a word that kind of implies a lock and key-like relationship, or it comes originally from the Latin I choose. And so lectins are very, very choosy molecules. They will interact often with these glycoproteins of the blood group in such a way so that they will have a specificity for one blood type, and a different blood type they would leave completely alone. So what do we know about them is that they're widely distributed in plants. And even when you take simple things, where this on the right-hand side of the results of an experiment done by a guy named Nachbar in the 70s, he just sent his assistant out to the grocery store and bought a bunch of foods, Kellogg's, Frosted Flakes, all sorts of things. And he looked to see what capacity just average foods in the diet were capable of causing agglutination in a way that had some blood type specificity, and he found roughly that 36 out of the 88 foods that they tested had this reaction. So really, what is a lectin? Well, there's a lectin. It even looks like a peanut, but it's really not a peanut, but it is the lectin from peanuts. So that's peanut lectin that happens to look like a peanut. And on both sides you see an erythrocyte, and you can see how the lectin is acting to bridge the surface of one cell with the other. Now, if you magnified this and multiplied it by 40,000 times, you'd have agglutination. You know, if you wanted to understand how it works, if you can imagine that you had just a box full of old tennis balls, and you chopped up some two-sided Velcro, and you threw that in the box, and then you shook the box up for a while, and eventually you would hear from this. It would start off with all the cells, all the balls banging around, sort of like randomly. But the more you agitate it, the more it would go from like da-dum, da-dum, da-dum to more like thump, 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 because as the Velcro kind of interacted, it would take the hair from one tennis ball and position itself in between and connect it by attaching to the hair of another tennis ball. And that's really the whole premise of the agglutination phenomenon in a very simple way. But agglutination is a very, very common fact of nature. Most of the time when we have an infection, that virus or bacteria or parasite is attaching to us via the process of agglutination. And of course, that's a big reason why there's so many differences in infectious diseases by virtue of blood type. So here's a simple list that shows foods that are known to have dietary lectins. And you can see here there's lots of different foods. And most of the common ones that we consume have some lectin in one form or another. The thing you start to notice if you look at the list long enough is that there's an inordinate number of beans, there's an inordinate number of seeds, there's an inordinate number of grains. There's a lot of embryos in the lectin world. And part of the reason that these types of foods have lectins is that nature couldn't give a bean an entire immune system, so it gave it a lectin as a sort of a primitive immune system that protected from having fungus until it could germinate. So a lot of the lectins are found in foods that are largely embryonic forms of the food. And if you think about it, most of the foods that we eat are the embryonic form of the food. For instance, when we eat beans and we eat grains, most of the elements are the part of the food that's the embryo. And most of these foods have lectins, and a greater portion of these lectins have some reactivity that could be predicted by knowing a person's blood type. So what do we have as a takeaway here? Well, a couple of things. One of the things about this whole system is that it has a kind of almost inverse correlation in terms of its importance. Now, if you just bear with me for a second, I'd like to take a step back and just say, all right, let's ask ourselves what sickness is and what disease is. And of course, it's pathology. You know, you go into a pathology book and they say this disease is characterized by this and so and so. But at its fundamental basis, most disease, most chronic disease, so here I'm going to leave out the types of diseases that you get by simply walking down the street and getting a safe dropped on your head. We're not talking about those. Chronic diseases, diabetes, inflammatory types of things, cancer, heart disease, are characterized by a phenomenon called aberrant glycosylation. So the word aberrant means weird, and glycosylation means putting sugars on things. So as we said before, we make glycoproteins by putting sugars on proteins, and we make glycolipids by putting sugars on fats. And that blood type is maybe the most important glycoprotein, that when we get sick or we have inflammation or chronic disease, our process of making these glycoproteins and glycolipids becomes disrupted. And so we start to get changes in the sugar profile of the tissues that are involved in that particular disease. And it turns out that, like I said before, since the glycosylation process acts like a zip code, that very often these cells will start to behave in very odd ways. So in many respects, if I take our tennis ball analogy and just kind of reverse engineer it, let's now take the experiment. Let's take that mental experiment, and instead of a series of well-beaten tennis balls, let's put in some Major League Baseballs, okay, and cut in the Velcro and put that in the box. Now, a Major League Baseball has some stitching, but it's very controlled and it's not all over the place. So if we were to take our Velcro and put it in a box full of Major League Baseballs, maybe we would get one or two that got the bad luck to be stuck together, but there wouldn't be enough fuzz to get the job done. Now, a Major League Baseball is basically sort of the equivalent of a healthy cell. The glycosylation, the sugar production, is normal and it's controlled. An unhealthy cell is sort of like the beat-up tennis ball. The sugar production is all over the place, it's uncontrolled, and it's not in any particular rational way. As we get sicker, our cells start to resemble more and more the beat-up tennis ball. So as we get sicker, the effect of eating these foods that can be predicted by blood type becomes more and more significant. So again, the amazing thing about the body, as I said before, we're omnivores to a certain degree. We can derive sustenance from just about anything if we had to. But in many respects, when we're healthy, there are many things about the process of this relationship that don't necessarily play out in our immediate reference frame. But as we get older, or as we get sicker, this relationship between these foods and who we are and our illness starts to become much more significant. Which leads me to the punchline, which is that if you look at all the types of people who are most enamored of these blood type diets, they're the ones who had some form of severe chronic disease and had marked improvement. And sometimes you'll hear people say, well, I did it for a while, but I didn't really notice much. Well, I guess we could say that you've probably got Major League Baseballs at this point in life. But the sicker you are, and again, there's that inverse relationship, the more these types of things are going to play into the process. And so by simply constructing, and you know, the medical literature is full of thousands of articles on lectins. Put in lectins in Medline someday, and about a week later you'll be done. It turns out that lectins are used in molecular biology all the time as probes. We use them to kind of map the surface of things. And that's a lecture in and of itself. But this is more of a survey type thing. And I just want to get the point across that we have differences in the molecular makeup of the digestive tract that are understandable by knowing our ABO blood type. And we have differences in the makeup of foods that have a specificity that's understandable oftentimes by the understanding of blood type as well. So what we have here is essentially the beginning of a theory, all right, that there's a certain type of intelligence that you can bring to the process of consuming your foods, that the only requirement is that you go stick out your hand and get your blood drawn and basically go to the Red Cross and give them a pint of blood, or buy a blood typing kit on Amazon and do it on your kitchen table, and bingo, you're all set to go. You're at the races. Now the important thing is that there's more to it than just this relationship, and I'd like to just share one additional aspect of it with you. There's an enzyme in your intestinal tract, in your small intestines. It's called intestinal alkaline phosphatase. Intestinal alkaline phosphatase is one of a class of alkaline phosphatases that they teach you about in medical school, but most of the time you spend your time worrying about the phosphatases in the liver and the phosphatases that are involved in when your heart muscle dies. Nobody pays any attention to the intestinal portion of alkaline phosphatase, which is interesting because it does two things of supreme importance. When you were 12 weeks old, it was the single most abundant enzyme in your body, because at that point in time, you started the beginnings of making the microvilli in your digestive tract. And so making large amounts of alkaline phosphatase had the effect of nurturing the growth of these very delicate parts of the intestinal tract that have to do with absorption. Intestinal alkaline phosphatase also does a few things in grown-ups. Number one, it splits dietary cholesterol. Number two, it increases the absorption of calcium. Number 3, it has a healing or trophic effect on the intestinal tract itself. It's been known since the late 1950s that blood group O has almost 3.5 times the level of this enzyme than blood group A. So blood group O has an enzyme 3.5 to 4 times greater that splits cholesterol and increases the absorption of calcium and has the effect of actually having a slight healing effect in the digestive tract in and of itself. Interesting thing. What turns on the production of intestinal alkaline phosphatase? Dietary protein. High dense protein activates the very enzyme that blood group O possesses that allows them to split the cholesterol, and they get the added advantage of having the ability to assimilate calcium become greatly enhanced. So what happens when you give a type O a sort of a more of a paleo diet, a higher protein diet? They generally do better. When you put that inside of a group A person who doesn't make a lot of this particular enzyme, and it's also been known that blood group A doesn't make a whole lot of stomach acid either, that these people, if you put them on a high protein diet, they're the ones who are going to have that whole cholesterol thing and all the other things that's associated with the downside of that type of diet. The interesting thing as well is that if you look at the people in the middle, because everybody says, well, what about, I'm a B, and you never talk about B. So what we know about B is that the diets actually sort of fall into that omnivore category, but they're idiosyncratic, because remember we talked about lectins. So here's 9% of the population that has a unique antigen that responds uniquely to a certain subclass of foods. And I'll just give you a simple example. If you take chicken and put it in some kind of saline solution and drop it on a slide of blood of group B blood, the cells will agglutinate. If you drop turkey on the slide of blood group B, nothing will happen. So chicken possesses an agglutinin that reacts with blood type B, but turkey doesn't. Now, how many people would ever say that there's a big difference when it comes down to things between chicken and turkey? Not too many. But oftentimes you will find people who have blood group B, who have difficulties with inflammation and chronic disease, and they're getting worse and not better. You do simple things. You put them off of chicken, you take them off some of the other types of reactive foods like corn and buckwheat, and all of a sudden their improvement starts to begin. So group B I classify as like an idiosyncratic omnivore. And group AB is so small, 2% of the population, that they fall within that kind of nether zone between B and AB. But when you talk about A and O, you're really talking about 85% of the population. And so the greater majority of people are much more easier to characterize. All right, let's take home some messages here. How to slow things down if you're type O. Low carb, lean meats, oily fish, sea vegetables, green leafy vegetables, aerobic exercise. Interesting thing, you remember back early on in the lecture I said there was a link between the outcome of the alleles that made a person type O and a certain regulation problem with dopamine? It has to do with this. There's a gene called DBH, dopamine beta hydroxylase, and this gene is responsible for converting dopamine into norepinephrine or noradrenaline, depending if you're from the UK or not. So epinephrine, norepinephrine, these are catecholamines. These are jittery things, right? They're part of your nerve signaling. They're part of your fight or flight reflex. So in general with type O, if they have an overproduction of this dopamine beta hydroxylase, they overconvert dopamine, which is a slow down, enjoy life, be happy molecule, to norepinephrine, which is a kind of agitated kind of HPA kind of thing. The interesting thing is if you look at the best things that have been studied that have the effect of regulating dopamine beta hydroxylase is exercise. And this again was something that my father had identified 50 years ago. He said these type O's were the ones who benefited really from a stress reduction. Everybody benefits from exercise, but stress, and to address the specifics of stress by a specific type of exercise, is a whole different game. So these people do better on this type of aerobic exercise. The interesting thing is if a type O is over-manufacturing norepinephrine, and a lot of this conversion takes place in the digestive tract, and strangely enough, again, it's actually promoted by one of the enemies of type O, which is wheat. So you wind up with this overproduction of noradrenaline, norepinephrine, and an underproduction of dopamine. The interesting thing about it is the tendency is to produce what's called type A behavior, right? So here's the paradox. You find type A behavior more commonly actually in people who are type O blood, not type A blood. Unhealthy ages, speeding that up. Wheat, corn, dairy products, sedentary lifestyle, excessive amounts of coffee, anything that's going to knock the HPA axis off. Type O is interesting even if you look at, as I said before, infectious disease. They tend to have more problems associated with things like chronic candida infections. And interestingly enough, it isn't even related to having larger amounts of yeast. They actually have been shown to have a greater propensity for having inflammation as a response to even normal amounts of yeast. And these people are like your kind of, I suppose you could say paleo, or if this was back in the 80s, we would say Atkins or Zone. You know, there's always been one version of that that's always been current and in people's minds, and it always seems to be the simple and easy solution to everything. And so we're saying simply is that 44% of the population is just going to do splendidly on the general characteristics of this particular type of diet. Here we got type A. These people are mostly Mediterranean plant-based diet. They do well on fermented soy products. And of course, this gets you into hot water with all the alternative nutrition people who really are totally dead set against soy, and yet the studies are pretty conclusive that soy protein has phenomenally beneficial effects on the lining of the arteries with regard to the diminishment of inflammation. It also has some profound anti-cancer effects. And the interesting thing is that the anti-cancer effects are much more pronounced in this particular blood type. Soy is not a particularly good product if you're type O, and certainly not a good product if you're type B. But you couldn't customize a molecule better designed to work inside of a type A than, believe it or not, the lectin that's in soy. So again, here's another lesson we can learn, is that lectins are not in and of themselves bad, because sometimes we can actually take advantage of that relationship. And it turns out that there's a lectin in soy that actually identifies early stage breast, colon, and ovarian cancer that actually tends to look like blood type A. It puts them at a big disadvantage if you have a cancer that looks like your blood type. But it turns out that the lectin in soy is able to tag those things and make them stand out a little better, so the immune system of type A doesn't get sort of derailed by something that looks like it itself. I made casual mention that there were differences in the stress response with regard to type A as well. We know that type A tends to have a lot of problems regulating cortisol. And so these are the people. And it's, again, you know, this is what the literature bears out. Since the 1950s, there have been almost 100 studies that looked at blood type and myocardial infarction, ischemic heart disease, peripheral artery disease, always showing a preference of blood group A. And the reaction here, of course, is going to be twofold. A, they don't have the digestive capacities to digest a lot of the foods that are known to promote heart disease in many people. But also, too, the stress response. It's been shown in studies that if you're type A, you tend to over-manufacture cortisol when under stress, and you have a decided inability to get rid of it quickly. And cortisol is a stress hormone, so we would like stress hormones to go up, but we would like them to go down. And the reality is with type A, and to a lesser degree type B, they go up, but they take a long time to come down. And that general tendency to have increased cortisol level and cortisol activity is really what does the damage. The high level that's done on a periodic or episodic basis is just nature doing its job. But at a moderate level that's been extended over a period of time is the one that has all the detriment. So they don't want to eat a lot of red meats, things like this. Again, ultimately, this is just the executive summary here. I'm just trying to give you some things that might even have some effect on age and control inflammation and stuff. B, balanced diet, but as I said before, idiosyncratic. Things that basically work better, for instance, lamb is a pretty good food, halibut, cod, a lot of things. Choline is a wonderful supplement in many instances in terms of being able to get certain of the pathways that are unique to type B. Things they want to stay away from, as I said, I mentioned chicken, buckwheat, rye, certain types of lentils, even sesames. Now, if you walk away from this lecture and going, well, the guy says that I should never eat sesames again, and you're type B, you sort of missed the point. It is related to the notion of essentially having an understanding of the possibilities of things, not the probabilities of things. If you look at how you could take this information and amortize it over the course of your life, you probably might eat a bit less sesame, and that would be perfect. Because when you're young and when you're healthy, there's a certain benefit at times even to consuming certain things that might be reacting. It allows the system to kind of fine-tune its responses. But when you're actually dealing with a malignancy or you're dealing with a chronic inflammatory state or something, that's when you take them out. And then, believe it or not, if the situation becomes controllable again and the situation is improving and the person's becoming balanced and normal again, then a small amount can be reintroduced with not too many difficulties. Again, type AB, idiosyncratic diet in the extreme. Why? Well, these people have an A marker and a B marker. They have an A antigen and a B antigen. So many foods that react with A or B can sometimes cause problems with this particular blood group. They tend to actually not have any antibodies, and so they don't react to too many things out there. And again, you know, we spend a lot of time nowadays discussing something called the microbiome, which is the sum total of all the bugs inside of you. And, you know, there's billions of these guys. But it turns out that some of them are found in specific blood groups and concentrations that are just outrageous. That there are certain strains of bacteria that are found 50,000 times greater concentrations in one blood type than in another. And that again harkens back to the idea that your blood type is a conditioning component on the environment. And I mean, even the latest things that have come up with regard to elements of what we understand to be epigenetics are showing a significance for blood type as well. So, you know, it's odd because it's a chemical that's been discovered for a very long time. I mean, we've known about blood type for ever. From the turn of the century, we've had this thing, and all these studies have existed. But, you know, we wind up with these things, and medicine moves on, and some of this starts to be viewed as just the sort of old stuff. And yet this old stuff is very, very significant. And I just want to share one final slide with you, and then I'm going to sign off. We took about 7,000 people and asked them basically via very unscientific internet type thing, you know, if they had lab results, that was great. We can incorporate them in the results. We had some interesting results. For instance, let me just pump this thing up. If you look at this, you see the 4 blood groups. You see that the percentage of people who reported with just the basic blood type, okay, ABO, is that roughly between 20 and 23% showed that they were doing no improvement. But between 75 and 80% showed improvement. And this was consistent across each one of the blood groups, which is important to realize that these people are oftentimes getting completely diametrically opposed diets, and yet they're reporting roughly the same level of satisfaction. So again, this kind of throws the idea that there's a one-size-fits diet, you know, all one-size-fits-all diet. We've got to rethink that. It's too simplistic. There's always things that are part of a healthy diet and always will be part of a healthy diet. I would kind of blew through that other slide there, but the reality is that there's just other ways that you can eat. And there's a line in one of the Jewish books called the Talmud. It's a prayer, and it ends in it's a bad translation, but it's feed me in ways that are convenient for me. And ultimately, the idea here being that, yes, your immune system can take a certain amount of this type of hit or miss kind of stuff. We wouldn't be here if that wasn't the case. But as you get older, you become compromised, you sort of want to be able to try to put as much information behind your choices as possible. There's some resources for you. I'm at the University of Bridgeport, the Center of Excellence in Generative Medicine. If any of you go on to have a career in naturopathic medicine and you ever want to stop by and say hello, just call first. And there's some other web resources there. I'm going to turn the screen back over to Dr. Yanis.
Dr. DAdamo, thank you so very much for that really exciting presentation. I'm sure everybody appreciated it as much as I did. So I just have a couple things to tie up. We are just about out of time. There were a couple questions. However, we're probably going to have to answer just one or so now in the effort of time. Any generally related naturopathic medical questions can be going to info@aanmc.org, which is on your screen. And I do want to notify you all of our next upcoming AANMC webinar, which is September 8th, focusing on heart-centered education in naturopathic medicine. So with that, Dr. D, there was one question in regards to gluten. I know you talked about wheat a bit. However, can you expound just a bit more on the varieties and how this relates to current concerns on gluten?
Sure. There's an interesting crossover between gluten and the lectin that's found in wheat and many other foods. And one of the things I find interesting is that many people report that they're improved by going on a gluten-free diet. And yet, when we actually subject this to whether or not putting people on a gluten-free diet is scientifically valid, and we actually go ahead and test people to see whether or not they have the genetics for gluten sensitivity or the other factors, it doesn't pan out. And yet you can't argue with the fact that these are people that say, well, I gave up gluten and I just feel a whole lot better. My joints are better, my migraines went away. I would venture to say that actually the thing that's missing, but the 800-pound gorilla in the room, is that we're calling something gluten when we should be calling it lectin. There's probably about 4 to 6% of the protein content of wheat, for instance, is wheat germ agglutinin. It is not a gluten. Gluten is its own thing, but it is a lectin. And being a lectin, it will cause potential for inflammatory reactions because of that agglutination phenomenon. And so essentially, what we have a case here, a classic case of mistaken identity. And that oftentimes when people are attributing a benefit to going gluten-free, they may have not realized it, but if indeed gluten wasn't their problem, they got the benefit from going lectin-free. And in essence, basically managed to see that it was gluten because that was the thing that they were looking for, and there's crossover between the two.
Well, Dr. D, thank you again so very much for this presentation, and thank you all for attending. This concludes the AANMC webinar today, and we look forward to seeing you at our next webinar in September. Hope you all have a great rest of your summer. And thank you again, Dr. D.
Oh, you're welcome.